Hello everyone, my name is Adam Michael Anthony Simpson and you're watching my YouTube channel, Adam M.A. Simpson. This is part 2 of my interview featuring Cellas Hayes, PhD candidate at Ole Miss. I hope you enjoyed part 1, learning more about Cellas' unique story and trajectory to higher education. Please like and subscribe to the channel and stay tuned for a really inspiring episode. So I'm going to pivot into the second half of this interview, which is more about your research. Explain to us your research field of pharmacology. How is your research at the intersection of pharmacology and neurochemistry, which is how I met you?
So, in a broad scale, pharmacology just means the study of drugs. I'm in an interdisciplinary department. So we have pharmacology, pharmacognosy, medicinal chemistry, and environmental toxicology. And all of us are in the same cohorts, the grad students and stuff. We take a few different classes, but it all overlaps because studying a drug includes all aspects of the community. If we start at the basic level of exposure with environmental toxicology, if we're out driving or we're out walking in the park and we breathe something in, you're exposed to it. If that causes bad outcomes or adverse outcomes in a population of people in a certain community, you take that and then you essentially look at that compound or whatever they're exposed to and see how it affects the body. As far as pharmacology, the study of drugs, you look at drugs on certain portions of the body or the overall animal or the overall system that you want to look at. Our lab, my PI, she has a PhD in neuroscience. So our lab focuses heavily on neuroscience, and she's the director of the neuropharmacology core. So we actually look at compounds and how they affect neurons and glial cells like astrocytes to make sure that, okay, if I'm taking this drug, how does it affect the neurons? Does it kill the neurons? And then a major part of our university is drug discovery and the Natural Products Center, which is attached to the pharmaceutical. So they discover and make natural products and compounds, and we test those to see if they have bad effects on different types of cells. And then we can incorporate those into in vivo models and see if there's a phenotype that's negative or that we that we don't want. So going from that part to that part, then we go to like the actual world view. I consider like pharmacology the foundation of where medicine is made. Before it reaches clinical, before it reaches anyone, it has to be done in an individual cell line, mutated cells, a certain type of cells, or an in vivo model. Zebrafish, mice, rats, ferrets, any of those.
Cool.
So pharmacology encompasses all of that. And in my lab, my work, I get to work with neurons, astrocytes, and mice as animal models. And then utilizing genetic approaches, we can modify these organisms to mimic the human body. For example, in my research, we look at IGF-1 a lot. It's insulin-like growth factor 1, and it's a hormone. So as you go throughout life, IGF-1 decreases to almost levels when you were a toddler. And as you know, when we get older, cognitive decline increases. Alzheimer's disease, dementia. So we look at the association between IGF-1 and cognitive decline or learning and memory, different aspects of that. So we can remove IGF-1 as a whole or receptors in cells or in mice. And we can choose a time point we want to do this, or they can just be born that way. And we can see how that affects them throughout life. Also in our lab, we have on campus, we're one of the major distributors of marijuana. So we have a marijuana farm where we grow 3 different strains, and basically we test CBD and THC in these models too.
Oh wow! Okay.
So you can see different levels of CBD and THC and how that affects animal cells and other terpenes that come from marijuana.
Oh, wow.
So it's pretty interesting and very translational, especially the part with CBD, THC, and stuff like that, since CBD and THC is becoming more popular and it's becoming more legal, which is major thing. No one knows actually like the outcome of if I use CBD right now from age 20 to 30, if I use CBD and use it in a bath, CBD oils, how does that affect me when I'm 60? No one knows that. And we as people don't think about that when we're young. So that's kind of the point of my research. The overarching goal is to understand how drugs and compounds, hormones affect life throughout aging, mainly advanced age. That's what we're interested in.
That's interesting. Yeah, and I love to go to the gym, and I'm seeing like CBD is the next biggest thing for inflammation.
Yes, literally. So that's a big thing. Inflammation. Everybody looks at it. There's a lot of funding going on right now for CBD, THC, and inflammation. And every disease that has inflammation as a marker or inflammation contributes to that disease. Everyone wants to look at that. And then the neurochemistry part, looking at the molecular structure and the chemistry of compounds to see, before we even go to cells, we have researchers that see if these compounds, based on their structure, do you think that they're going to kill cells? Because, of course, if they have a similar structure to a compound that we already know kills cells, there's probably not a reason to test it or to waste money or to waste resources on it if these compounds are similar. Okay,
that's cool. I'm partly jealous because like before I decided to come to study environmental engineering, I actually really wanted to do natural products research, which, I mean, you're not necessarily doing natural products chemistry, more synthetic chemistry, but yes, that whole field to me is very interesting.
Yeah. So I guess 3 years ago, we had a project funded by NSF, International Research Experience for Students.
Oh, wow.
And it was funded like 3 years, and I was fortunate enough to secure a position, and we actually got to go to Poland for 6 weeks and do natural products research. So compound extraction, field work, finding different fungi and plants that we think would have properties for anti-cancer properties. So I've done a little bit. I definitely enjoy the pharmacological aspects more than,
of course. Yeah.
It's just like all those chromatographies and all the waiting for compounds and just so much of looking at structures. I thought I got away from structures and heavy chemistry until they told me I had to take toxicology for grad school. Okay, more structures. More structures.
That's cool. Yeah, cleanup is most of the natural product stuff. But yeah, do you want to talk to me about your review publication that's you've submitted on insulin-like growth factor 1 and ischemic stroke outcomes, evidence from clinical and preclinical interventions? Do you want to talk more about that?
Yeah, I can. So in this review, we comprise data from hundreds of other papers that looks at the preclinical and clinical aspects of IGF-1 as a therapeutic for ischemic stroke. So as you know, as everyone knows, as we get older, stroke incidence increases. But like I said, IGF-1 levels decrease throughout age. So that's kind of the connection. If IGF-1 gets lower and stroke incidence, there could be some type of connection there. So in the preclinical aspects, a lot of studies have looked at giving exogenous IGF-1 before, during, or after inducing stroke in multiple types of models. And the overall consensus is that if you give IGF-1 at any other time around you induce stroke, you will get a better outcome. There are less neurological deficits, it's less behavioral deficits, and less inflammation. If you look at cells, there are less neuron death, less astrocyte death, less reactive astrocytes. So overall, IGF-1 is good for stroke outcome. In the clinical aspects, if you look at IGF-1 levels in stroke patients, lower levels are associated with and correlated with basically poor stroke outcome, unfavorable outcomes, mortality, and sometimes even a secondary stroke. So low IGF-1, bad in people, it promotes death and bad outcomes, neurological deficits, and along with behavior deficits. And then in the animal part, where we do the pharmacological aspects of it, we basically give IGF-1 and see how that affects the animal and is beneficial overall. And then in different cell types in the brain, we have neurons, astrocytes, microglia, and oligodendrocytes. IGF-1 promotes the survival of all of those in different ways and support through each other. So the entire review has sections on IGF-1 in neurons and how that's beneficial to stroke outcome, IGF-1 in astrocytes and how that is beneficial to stroke outcome, along with analyzing other people's primary data and how if IGF-1 is beneficial for stroke outcome in people and in rodent models. So that's essentially the gist of it. That's the overall broad view. We also note that there is some conflicting data out there. However, it is a lot less than the overall consensus. So
Usually
hopefully
it's the same.
Yeah, it's usually the same. There are usually a lot of times the conflicting data come from one or two labs, and they oftentimes have one or two or three publications on this same topic. So it's interesting to see that and to see the way that they do things. But it is essential to understand the whole part of science. If everyone agrees, I feel like it's not science. So everyone agreed once we map out the genome, everything will be handled. Clearly, that's not the case. Clearly, that's not the case.
Cool. That's cool. So, what are you looking for professionally after you get your PhD?
This is the question that every grad student dreads.
I know.
So, ideally, in my perfect world, I would pursue a postdoc. Since I have been here for 6 years almost, and I would be doing same research with the same lab for probably 7 years by the time I graduate. I want to get into something new. However, I still want that pharmacological aspect to it. However, I think I want to look at something towards diabetes or hypertension, something that affects minorities more than other races and ethnicities. I know that is. So that's one reason I switched to stroke research for my dissertation. That is the reason why mainly. Things that affect minorities often get left on the back burner a little less. So wherever I go, I want to do that. My other option, which I think about often, a lot of times, I'm really interested in policy. So I often think about doing like a science policy fellowship. Triple S, and doing those, and then running for public office and eventually running for president. It's kind of two opposite ends of the world. I don't know what's going to happen, but I feel like the same way with me going to high school and undergrad to grad, something's going to happen in my life and it's going to shift me in one direction or the other. But right now, I'm planning to do a postdoc. My eyes are set on postdoc and networking and getting the science done.
Okay. All right. Well, I'm going to link your website and hopefully have your CV on the website too.
Yes.
And so anyone interested can check out the link in the description. But I'm so for running for public office. I think it would be really nice to have more STEM PhDs in public office.
I agree. public office, not as advisors.
Yes.
Advisors are nice,
yes.
but advisors don't make the final decisions.
Exactly. So
I think it'll give a very unique background. And pursuing a PhD, it gives you all the essential skills to run a certain part of the government or the entire government. So we
PhD,
we run people. We don't run people, but we run cells and we run animals a lot of times. So and we have to deal with a lot of people. So I think all of that helps.
Yeah, and a PhD is really teaching someone how to learn and how to go about learning in a systematic way. So I think it is really good training for a politician. And we also know that having a different voice to shake up things is always helpful in getting to the best solutions to certain problems.
It is. Diversity in people.
Yeah, exactly. So last but not least, which is my favorite question, what misconceptions of graduate school would you like to dispel?
I would say the major one is you don't have a social life during high school. Clearly, Adam has a social life. He has time to run this awesome YouTube channel. So he has time to do that. I have a 2-month-old son. I play tennis. I work out. I spend time with my family. I go on trips with my friends. I feel like the biggest thing that grad students struggle with, and undergrad students overall, and probably people in general, is time management. Time and planning can make grad school a breeze. As you plan out your experiment, you plan out everything you're going to do week by week or month by month, and you do it, that takes so much off on you, and your mentor, your PI will notice that. You're one less person on their list that they don't have to worry about, because they know that you're doing it, and that just makes your life easier. Another thing is you only have to focus on the research. You can seek out other opportunities. I serve on diversity and inclusion committee for the university. I'm a graduate school ambassador. I have 2 external fellowships that I have to do work for. So it's a lot of things that you can juggle at the same time. And I feel like if your mentor does not let you seek outside opportunities, they're lacking in that mentoring area, because those are essential to being a good scientist, to building your network, building community, and even translating your science into the community. People often think that research is the most important thing that you should pick when going to grad school, but it isn't. Your research, if you think about it, is a fraction of a percentage of the things that people are studying out there. Does it matter? Yes. If you think about it in a broad scale, does it matter? Not really. However, what matters is how you do that research and the person you are when you come out of that. So the person that basically is going to be your new best friend, your new significant other, is your mentor. Mentor is over research. When even trying to choose grad schools, although I only applied to 1 grad school, I essentially emailed 8 other professors from across the country, and I think I got 2 replies. One was retired, one didn't have any other positions. And that's just one way you can go about it. If you can email people and they reply to you, or if they reply to you and even tell you no, but forward your contact information to someone else, that shows you that they actually care about you, even though they don't know you, and they care about the science and the people. And choosing a good mentor can make or break your graduate school career. And even people who have to do rotations during the beginning of grad school, I didn't. Our program doesn't do that. We have to have a professor accept us before joining.
Same for our program.
So people who do rotations, you should consider the same thing. You may not like this person's research more, but I can do research that I don't like. I cannot have meetings and talk to a person that I don't like every single week. and I cannot work closely, because if you don't like someone, that's already your own edge. Mm-hmm. Science, you're on edge even more because it doesn't work ever. Yeah. So when something doesn't work, two things just like clash out. You attack each other. So choosing your mentor is probably the best advice, the best misconception that I can say people have. They're like, well, I want to do this type of research, or I want to pursue this type of degree. I never thought I would get a PhD in pharmacy, because that's where my PhD will be in. I'm interested in neuroscience, but none of the neuroscience professors and research that I was interested in replied to me, or they didn't have positions. So even choosing a certain degree program kind of boxes you in. Once people say PhD, they oftentimes don't really care what it's in.
Yeah, exactly.
So, for example, our department is interdisciplinary. People have PhDs in toxicology, people have PhDs in neuroscience, and they teach in a pharmacy school, teach PharmD students. And you can even teach at medical schools with a PhD in toxicology and stuff. So not necessarily boxing yourself in saying, I'm going to apply to a program that is a PhD program. Choose a program with a mentor that's going to kind of get you towards your end goal of having some type of career. I said I have two careers. It's either postdoc and professor or being president. Yeah. And like PhD in pharmacy, I understand people on one side, and I also do the research. So that kind of helped me do both of them. And that's really my big advice about those misconceptions. They can make or break your grad school experience. It is not supposed to be the worst time of your life.
Wow. Thank you for that. I've heard that advice from others before, so that when multiple people say the same thing, that there's truth in it. And I think mentorship, your mentor is very important. Research important, but less so. Mentorship is more important, and your advisor and who you pick for your advisor. So really like that one. So Cellas, thank you so much for agreeing to be on this interview. Is there anything else you'd like to say before?
Adam is awesome. Adam has awesome YouTube channel. I watched like 10 videos.
Oh, really? Damn, thank you.
Yeah. Me, my girlfriend, and we had the baby in there watching too. So we all watched the YouTube channels at home on the TV. I was like, this guy asked me to do a YouTube interview, and I just want to thank you for the opportunity to spread my voice a little bit to the world. And if one day I can do the same to you, I will definitely put you on that list and reach out.
Thank you. And please do. Awesome. Thank you so much, man. And have a good rest of the week, and happy Black History Month when it comes.
Yeah.
Yeah. All right, man.
See you later.
Thank you for watching the entirety of this interview featuring Cellas Hayes. I hope you enjoyed, and stay tuned for more.